now.
All right, welcome to our 404 presentation for Teach Yourself. I'm Porter, and this is my group, Trevor, Spencer, and Justin, and we're group 2-4, and we're doing our Teach Yourself on the concept of the Docker and its ability to create containers. And so in the next slide, we're going to cover just a brief overview of why use containers, why this stuff is relevant to us. And so as you can see here, we have two illustrations. The one on the right being for the setup we all know that is using virtual machines, multiple virtual machines on a computer. And the one on the left is using the Docker and its ability to create containers. Something important to note, just kind of the main point of it, is that Dockers are more efficient in their ability to be more portable, more efficient with allocation of resources, and just consistent overall. And so, as you can see on the left, the Docker or the infrastructure is the same. It's over on the bottom, and that's like your RAM, your CPU, all that stuff. On top of that, you have the host operating system. And as you can see, that is the operating system for each one of the individual apps above. The Docker is kind of the bridge, which enables you to create those multiple apps and have them all on the same operating system. And the result is that each app doesn't have a specific allocated amount of the infrastructure to it, unlike a virtual machine. Each one has only what is necessary to run the app. It's more dynamic in that nature and more efficient. If you look at the one on the right, each virtual machine up at the top has the same infrastructure at the bottom. The hypervisor enables multiple virtual machines to run. Each virtual machine has its own app and its own operating system and its own allocated amount of infrastructure from the host. And the result of that is you can have underutilized resources and it's more of a hassle and less consistent overall. And so that's kind of why we decided to dive deeper into this and explore the concept of containers. And so the next slide will kind of hit on what we're going to talk about and what we actually did to explore this. The first part being just basic Docker deployment, followed by just using AWS to deploy a static website, and then finally integrating it with Elastic Container Services, EC2, and Beanstalk. So that said, actually go on to the next slide real quick. This is the outline that we followed, the instructions we used to actually create this Docker. And so this is what we'll be referencing throughout the presentation. And so now I'll pass it over to Trevor to go more in depth with this.
Awesome. Thanks, Porter. So first off, just kind of as we're getting started, the base things that you'll need to be able to follow along and accomplish the things that we did. So first off is a basic Amazon AWS account. Next is a Docker Hub account. There's an example of what that looks like in this screenshot on the right. Then the command line, we'll be configuring things from the command line. And then finally, access to GitHub, because we cloned the GitHub repository as part of the tutorial that Porter mentioned on the previous slide. Now moving on to talk about some helpful terminology just to set the groundwork for what we're going to be talking about. First off is an image. So an image is a blueprint of the application. It's the basis of the container. So think of it as similar to a GitHub repository. We can copy this image from a Docker Hub and it gives us certain functionality. That command right there, docker pull busybox, that's an example of how we can pull down an image from the Docker Hub. Next is a container. Container is exactly what Porter described at the beginning. It is created, so the container itself, we talked about the concept of a container. It's just a lightweight way to run to separate and pretty much have a virtual machine. So the container itself is created from the image that we pull down from the Docker Hub, and it's what actually runs the application. Professor Schetzler said that he gave the example of running a container. He would have a container with an app that ran the Python code, another container that ran the Postgres database and things like that. So you can have all these separate containers and then you can have them work together to have a really lightweight solution. Next up is the Docker daemon, which is the background service. It's just the special word they gave for the background service running on the host that manages everything related to how the client communicates. Next is the Docker client, which is just the command line tool that allows the user to interact with the daemon. And finally, Docker Hub, and we'll go ahead and pull it up and give some examples. But it's a registry of Docker images that have different functions according to what the user wants to do. So we already mentioned a couple of them. For example, Python or Postgres, we can just scroll through and see these are just Nginx. BusyBox, which is one of them that we used as we were creating our app. And there's a handful of others. So you can just kind of get an idea for the different things that you can run in a container and the applications for a container. So heading back over, a few more helpful words. There's the idea, the concept of a base versus a child image. So again, an image was that thing that we pulled down from the Docker Hub. So a base image, it's standalone. It doesn't have a parent image, and it's things such as Ubuntu, BusyBox, Debian, things like that are base images. Child images are built on top of base images, and they can expand the capabilities and add functionality to another image. But they're reliant on the parent image or another base image, for example. Next is the concept of official versus user images. Official images are things created by Docker itself. So for example, the Python or BusyBox or other ones like that are official images that are maintained and created by Docker. Next are user images, which are created and shared by users. And that's what we did for our app today. And with that, I'll go ahead and pass it on to Spencer.
Awesome. So now that we kind of have that underlying framework, that understanding of what Docker is, what containers are, what images are, we want to walk you through what we did to kind of get our hands dirty here and to deploy an application using Docker. So I'll kind of walk through the steps and what we did, and then we'll finish with the demonstration by Justin. So the steps that we did in order to start using Docker is you have to install Docker on Linux. We used a tutorial that we mentioned earlier in order to install Docker. And once you have that installed, you can run commands to interact with what's called Docker Hub. That is where all the images are stored for Docker. You can access images that other people created, your own images, custom images. You can copy images just like you clone GitHub repositories. So once you have Docker installed, you can do all of that. We ran this command, docker pull BusyBox, which Justin will show a little bit later. And that is pulling a Docker image that someone created. And that's kind of how you can run commands to interact with different images that have been created. The images that we have kind of played with is we first played with BusyBox, and then we made our, if you want to jump to the next slide for me, we made our own image using Docker. And that's a custom image that we made on our own Docker Hub, kind of like our own repository in that situation. And that's what we used to eventually deploy, to jump into the next slide, to deploy to AWS. So once you make an image, you can simply download the code that you've created and deploy to a Docker EC2 instance, just like we did with our other applications using Elastic Beanstalk. And that will allow you to deploy that container, that specific container of code through AWS.
Awesome. Thanks, Spencer. So now we'll just show you a little bit of what we did to get this set up, a little bit how we familiarized ourselves with Docker, and then how we deployed, and we'll show you our deployed side as well. So we'll go ahead and hop over to a Linux terminal here. And after you have Docker installed on Linux or on Windows or Mac, if depending on your operating system, we can go ahead and pull all of our current images on Docker on this machine. So if we run Docker images, you'll see we have 3 or 4 different images that we've used, including BusyBox, which we mentioned is just a base image, and Hello World, another base image that we'll test out, kind of to get familiar with Docker, as well as some other ones. This is a user image that we downloaded, and this is our own custom image that is running off some GitHub code from another repository. If we want to test these out, let's test out Hello World. We can just say Docker run and then the name of the image, and you'll see if we run that, it'll generate the image, set up the environment, run the code, and then close that container. And so all this was programmed to do is give a little message and some other information and then close that container. So if we want to test another one, if we wanted to test our BusyBox image, we can do Docker run BusyBox, and you'll notice there's no output. It almost seems like it didn't run. Well, this image, like I say, is set up to where it needs commands to execute. So when you run an image, it's simply running the image file and setting up your container or your environment. And then there's other things that will execute within that environment. So we need to provide this with a command or something, some code to run inside of that environment for us to see anything. So if we run Docker run busybox and then provide it some code to run within that images environment or container, you'll see when we run that now, it will execute that code after opening that container and then close it back down. So very cool. Now we'll play around with our custom image. Like I said, we made our own custom image, have some code on GitHub. And in order to run our code locally through a container that we can access through the browser, we can say Docker run, and we'll give this a specific port number so we know which one we'll use, which will be 8888, and then the name of our custom image. And when we run that, you'll see we'll have a message here that it is now serving our app at that address. So we'll go to our Ubuntu instance. We'll log in here, and we'll open up the browser to that port. There we go. Got it. And we'll open up localhost 8888, and you'll see that our site is running at that port. And it's just simply a cat GIF. It'll generate different ones every time you reload the site. Pretty cool. So that's how we run it locally. And I will show real quickly how we deployed this. So since we have this custom image in Git or in Docker, we push that image to Docker Hub, which is just like GitHub. And here's our image in Docker Hub that we can then use publicly. So if we select this Spence K12 catnip image and then select the latest one, you'll see the different program files that run. They're basically automated scripts to set up this image so that when multiple people use this image, they'll have the exact same environment across platforms. And so you'll see these different script files to set up that environment for us, setting up different environment variables, installing certain things, and so on and so forth. And so we use this Docker Hub repository to deploy to AWS Elastic Beanstalk. And it's very straightforward actually how to do that. If we go to AWS Elastic Beanstalk, you'll see we set up an environment that's running in Docker. So we'll go to that environment here, catnip env. You'll see our platform is Docker running on 64-bit Amazon Linux. And we simply provided it our Docker Hub repository. And you'll see now it's deployed, had a live URL. We'll go ahead and click that. And there's our site open on the internet for anyone to enjoy these special cat GIFs. So that's how we did it. It was a really fun experience. Docker seems really cool, and there's a lot you can do with it, and it's very flexible and dynamic. And yeah, that's Docker, and that's what we did for our Teach Yourself project.